In this short video, we're going to look at how to find the area enclosed by the function y equals root x, the line y equals x minus 2, and the y-axis. So first up, with any of these problems, we need to draw the graph of it, just a sketch. And if we've got y equals root x is going to look something like that. That's y equals root x. And then if we draw in the line y equals x minus 2, it's going to go through -2 and 2, like that. And we're now going to be looking read the instructions. It says underneath the curve, above the line y equals x minus 2 and the y-axis. So it's going to be this area in here. To find the area between two curves, we need to find where they meet. Now, in a sense, we don't need where it meets at the bottom here, because that's beyond the question. So it will meet here at 0, but we need to find where it meets at the top, up there. We need to find what the number is there. So what we need to do is we need to solve where x minus 2 is equal to root x, and if we squared both sides, then we'd have that, which is going to be a quadratic. And shifting the x to the left, we get that, and if we're to factorise that, that should give us a pretty good clue of what we're looking at. And x is 4 or negative, x is 4 or 1. The x equals 1 is not part of what we need to know here. What we do need to know is that that is 4. Now we need to find the area between them. So it's the area, the total area is the area under the top curve, which is between 0 and 4 of root x, minus the area under the bottom curve, and that curve is x minus 2. We could put them all together, in fact, because we've got the same limits. The integral of x to the square root x to the half would be 2 over 3 x to the 3 over 2 minus the integral of x, which is x squared over 2, minus the integral of 2, which would be 2x. And if we do the num crunching on that, we get that the answer is 5 1/3 square units. Some of you may actually be wanting a little bit more information about that one, about where this point is here. Well, y equals root x, the curve for that doesn't just have this top bit here. It has this bit down here as well. And so we've got the curve that goes up like that. So this bit is where they meet here at 1. And that bit is where they meet at 4. But we're actually not interested in this bit because we needed to know where it met at the y-axis over here. So we're not interested in the point at x equals 1. We're interested in the whole area across there, going from 0 to 4, not from 1 to 4. So in case you were wondering why we didn't look at the 1, it's because it's tucked inside the curve that we're looking at.